Okay. So then we came here, since she's riding 6 miles an hour, these are in minutes, so 60 minutes will give her 6 miles. Then 50 minutes will give her how many miles? 5, 4, 3, 2, and 1. So the distance over time equals, does anyone think they have the equation for this? What? X plus 6, I'm adding 6 to my time, so 10 plus 6 will give me 1. 20 plus 6 will give me 2. What am I doing to this time to get this? What am I doing? Dividing by 10. So it's the time divided by 10. Which gives me my hours. Any questions over that? Okay, this one here. Okay. Kathy, she can run a mile in about 10 minutes. So this would be minutes per mile. Okay, so this is what I'm going to say. I ran 6 miles. How long does it take me? So the miles now are the input. And so your output is the time. So this one's a little easier because after 1 mile, how long did it take me? It took me 10 minutes. 2 took me 20. 3 took me 30. 4 took me 40. This is 50. This is 60. Any questions over that? Okay. So the time over distance okay, what am I doing to the 1 to get 10? So 10 times the distance. Any questions over that? Okay. So now, we should have graphed this. So for 0, we're going 0. At 10, we're at 1. At 20, we're at 2 miles. At 30, we're at 3 miles. At 40, we're at 4 miles. 50, 5, 60, 6. Let's just keep going with this. Okay. The domain I don't want you to give, you could have given me like a x is greater than or equal to, okay? But the key is I want to know what this domain represents. What is the x-axis representing here? The time. Okay. The time in minutes. And for this, it's x should be greater than or equal to 0. Because I'm not going to have negative time. And it doesn't have an end really necessarily. We can continue to run forever. Okay, this one, Again, we're going to do our ordered pairs. So after 1, we're going 10. 2, we're going 20. 3, we're going 30. 4, we're going 40. 5, we're going 50. 6, we're going 60. Okay? And 0. So this is my line here. Now for this one, the domain of the function, what is the x representing here? The distance. Any questions over that? Okay. So on the back, the above functions represent Michelle and Cassie rates are inverse functions. Okay? That's what this whole chapter is about, is inverses. So we need to identify some characteristics of inverse functions. So everybody, identify some of the things you notice about those two functions. Okay, about the equations, about the ordered pairs, about the graphs. Write down some characteristics of inverse functions. Okay, Robbie, what is something that you noticed about the graphs and or the ordered pairs? Or they're running at the same pace, yes. Michelle and Kathy can definitely run together and be okay. Okay. What did you notice about their ordered pairs?
Pretty much the same, just like switch.
Very good. Let's see. Can you read this at all?
Yeah.
It's like, I don't know. Let's try this again. The ordered pairs are the same, but the x and y values are switched. Okay, so if you look back here at our ordered pairs, here we have 10, 20, 30, 40, 50, 60 in the x place. Here the y value is 10, 20, 30, 40, 50, 60. Here in the y it's 1, 2, 3, 4, 5, 6. Here in the x it's 1, 2, 3, 4, 5, 6. Okay, and it's the same values that is switched places. Okay. Okay, anyone else notice something about it? Yep. Okay. The axes are switched. Okay, is there anything else we noticed? Yep. Very good. The equations have the opposite operations. In one of them, we are multiplying by 10. In the other, we're dividing by 10. Okay, so in multiplying and dividing are opposite operations. Thank you. Yes. Yeah. Yeah, the distance over time and time over distance, yes. Which is kind of like the axes being switched. Okay, the X and Y are switched. Okay. Any others? We're good. Okay, so just like this is distance over time, then it was time over distance. This one's divided by 10. This is multiplied by 10. Okay. Okay, so this is true. All of these things we talked about is going to be true for all inverse functions. Inverse functions are just functions that undo each other. Okay, if in one I'm going to add and the other one I'd subtract because I want to undo it. So the first thing we talked about is that the ordered pairs are just switched. The X and Y values are just switched. And that's the first thing we're going to do right here. Inverse relation, if AB is an ordered pair of a relation is just a group of ordered pairs, then BA, we switch the X and Y, is an ordered pair of the inverse. So for this, here's my X values, here's my Y values of my first relation. Okay. To have the inverse of it, I just switch them. So I'm going to take all my X values and replace them and put them where the Y is. Get negative 1, 0, 1, 3. I'm going to take all my Y values then and replace them and put them where the X goes, which is negative 2, negative 1, negative 1, and 4. Any questions over that? Okay, do the next one on your own. Find the inverse of that following relation. Quiet, please. Okay, so this again, you're just going to replace them. So the X values are going to be now your Y values. So 3, 6, 5, negative 2. And then your Y values are now going to be your X values. Negative 3, 7, 2, and 1. Any questions over that? Okay, the idea of an inverse is just that it's undoing it. Any operation that's performed, you do the opposite for the inverse. Okay, so you just describe the sequence of operations performed on the input value of X by the function f of X. Okay, so we want to take this equation, and if I plug the number in for X, what's the first operation I would perform?
Multiplication.
Very good. So the first thing I would do if I plug the number in here is I would multiply by 3. After I multiply by 3, what would I do? Subtract that 2. For the inverse, to describe the inverse of each operation, in reverse order. So we want to take these operations, do the opposite, or the inverse of that operation, and start backwards. So instead of subtracting 2, what's the opposite of subtracting 2? I would add 2 first. Then we do the inverse of multiplying. So what's the opposite of multiplying? We would divide. By 30. Thank you. Okay, now to write the rule for it, this is the notation we use for the inverse f of the negative 1 of x, f to the negative 1 of x, which is just the inverse. So the first thing I'm going to do is take x and I'm going to add 2 to it. I'm going to put it in parentheses so I know that's the first thing I want to do. Then I want to divide by 3. And division is a fraction, so we put 2 on the bottom. Divide the whole thing, not by 2, but 3. So that is the inverse equation. Okay, so this equation and this equation are inverses of each other. They undo each other because they have the opposite operations in them and in the opposite order. Any questions over that? Okay. Next one. You have it on the back page. You guys stapled. Page 27. Find page 27 in your packet. They were numbered wrong. They were numbered wrong, so. I think I'm going to do it with you. The inverse. Okay? Okay, so now I'm going to describe the sequence of operations performed on the input value x. So if I plug the number here first, okay, Garrett, what are we going to do first here? Let's square it. Okay, Elizabeth, after I square it, what would I do? Add 4 to it. Okay, now we're going to describe the inverse of each operation in reverse order. So we're going to start here. We're going to do the inverse operation. Okay, inverse of adding, subtracting. So I'm going to subtract 4 first. Okay, then we need to remember what the opposite of squaring something is. Very good, square rooting. Okay? So the opposite of squaring something is square rooting. Yes. Yes, you reverse the order and do the opposite operation, or the inverse operation. Okay, so this is going to be the inverse of x equals, we're going to take x, and we'll do that first operation. Subtract 4 from it. We're going to put it in parentheses so I know that's the first thing I'm going to do. Then I'm going to take the square root. Okay, take the square root of this. The whole thing, because in parentheses, you want to do that part first. Now, whenever you square root something, you need a plus or minus sign. So you have to add the plus or minus sign. Plus or minus the square root of x minus 4. Okay? And these two equations are inverse functions. Any questions over that? We're all good? Yes. You can just do the inverse. I'm just writing it out to show you the reasoning behind it, okay? In fact, this is actually kind of a harder way of doing it, especially if you have more complicated equations. So I'm going to show you the easier way and the way that you could probably do it in your notes, that might, or in your homework. That might be a little bit easier. Okay? This just gives you the reasoning behind what we're doing. Okay? So we talked about in that first example that the x and y just switch. Okay. You can do that for the equation as well. If you just take the equation, okay, remember this equation is the same as if we wrote it like this. Y equals 2x squared plus 3. If you switch the x and y is what you're first going to do to solve this. Okay, this is just another way to do what we just did. So here's going to be the x over here. Then you're going to have 2y squared plus 3. Okay. Now the second step to finding the inverse is to solve for y now. So by solving for y, we're going to do the opposite operations. So that will help us find the equation. So here to get that y by itself, I'm going to subtract 3 from both sides. I'm going to get x minus 3 equals 2y squared. Then I'm going to divide by that 2 to get the y squared by itself. So then I just have x minus 3, everything all over 2, equals y squared. Now to get rid of the squared, I'm going to square root both sides. Okay, that's going to give me y equals plus or minus the square root of x minus 3 all over 2. Make sure you have that plus or minus, because whenever you put a square root, you need that plus or minus. Any questions over that? Okay. Now to determine if it's a function, we want to graph it. So we're going to start by graphing just the f of x. The f of x is a quadratic. Yes. Thank you. Okay, the f of x is a quadratic. So we need to identify the vertex. We go back to the equation, 2x squared plus 3. We need the h and the k values. Does anyone know the h and k from this equation to find the vertex? 0 and 3. The 2 is the a value. There's no number inside a parenthesis with the x, so that is a 0. So we have 0, and then the k value is 3. So that's your vertex. The a value was 2. So our first step is just to go up 2 and over 1. Up 2 and over 1. And then this is my parabola. Any questions over that? Okay. I'm going to write the ordered pairs because it will make our life easier. Because we haven't really talked about how to graph a square root. Okay, so we're going to show you how to graph it using the ordered pairs. So my first ordered pair I have here is -1 and 5. The second ordered pair is 0 for x and 3 for y. The next one is 1 and 5. So then my inverse would be switching the ordered pairs. So it's going to be 5, 3, 5, and then -1, 0, and 1. Okay, so you want to switch the x and y values to find the ordered pairs for your inverse. Okay, so we're going to go on now where x is 5 and y is -1. We're going to go where x is 3 and y is 0. And go where x is 5 and y is 1. And this is my inverse graph. Okay, notice the inverse is just the parabola flipped on its side. All inverses reflect across the y equals x. Okay, so if I folded my graph right through the origin, okay, then they would be the same thing. Okay, all inverses will be like that because you're switching the x and y values. Okay, so if you just reflect it across at y equals x, you can lay them over each other. Okay. Then we have to remember if this is a function or not. Okay, remember at the very beginning of the year we did a vertical line test. Okay, I took a vertical line, I went across my graph, and if it touched in two spots, would that be a function? No. Since my x repeats, 5 and 5, it repeats, this is not a function. Since my line crosses in more than one spot, this is not a function. Therefore, it's not a function. Any questions over that? We're all good? Okay, next one, we'll do the same thing. We'll replace the x and y. So we have x equals the y minus the 3, the whole thing squared, plus 5. Then we're going to solve for the y. So you're going to subtract that 5 minus that 5. You're going to get x minus 5 equals the y minus the 3, the whole thing squared. Let's see, Vanessa, what should we do after that? Very good. We're going to square root both sides. Okay, if I square root this side, I need that plus or minus in there. This just cancels, the square and the square root cancels, and I get y minus 3. Any questions over that? Then I'm going to add the 3 to both sides. Can I add this 3 and this 5? No, I cannot. Okay, one is inside a radical and one's outside. They do not get to hang out. Okay. So I'd take plus or minus the square root in parentheses x minus 5, and then plus the 3 outside the radical, and that equals my y. Yeah. You can, yeah. Most of the time you would see this written, if you saw it in a book, you would see it like this, because this is in vertex form. So, because this is going to be similar to our parabola, so they'd have the HK like this. So that's why I wrote it like that. But you can have the 3 in front, yeah. So I'm just switching it around so that yes.
Why don't we solve it in the parentheses, like in the beginning of the equation?
Like here?
No, like the basic, yeah.
Oh, multiply it out, because that's going to be way more complicated.
Oh, okay.
Yeah, because then you got to factor it again after you added the 5, and this is what's much easier.
Okay.
Yes, but you could do that. Any other questions? Okay. Okay, so now I'm going to go back and graph. So again, we need the vertex. So now let's what's the vertex of our original equation? Negative 3, 5. Okay, remember you switch the sign, yes? Is 3 negative or positive here? Oh yeah. Switch the sign here. This is a negative, so you have to switch that sign inside the parentheses. So it should be a positive 3 and 5. So your x is 3 and y is 5, which is right here. Then we take the a value. Lance, what's the a value in the original equation?
0.
What number's in front of here?
Oh, 1.
It'll be a 1, not a 0. A is 1. So then my pattern is a over 1, and then 3a over 1. Let's see. 3a over 1. So we're going to go up 1 and over 1 will be that first step. The next step will be up 3 and over 1. 1, 2, 3 and over 1. 1, 2, 3 and over 1. And then the next step would be up how many? 5 and over 1. Okay, remember that from graphing our wonderful quadratics first semester? Yay. Okay. So that is our graph. Okay? Again, I'm going to write my ordered pairs. So when x is 1, y is 9. When x is 2, y is 6. When x is 3, y is 5. When x is 4, y is 6. And then when x is 5, y is 9. I'm sorry? Okay, so now we're going to just switch them for my inverse. Okay, so now all of my y values are going to become x values. Okay, so when x is 9, which is right here, y is 1. When x is 6, y is 2. When x is 5, y is 3. When x is 6 again, y is 4. And when x is 9 again, y is 5. So this is my parabola. And again, it's going to reflect across the y equals x axis, or y equals x line. So they're the same graph as I folded it over. Okay, and is that new function, new graph or function? No. Madison, why is it not a function? Very good. My vertical line, if you take my vertical line and then moved it across my graph, it would hit in 2 spots, so that's not a function. Functions can only cross in 1. The parabola is a function, but when I reflect it across the y equals x, the inverse of it is not. We can also look at the ordered pairs and see that the ordered pairs, the x values repeat, the 9, 9, 6, 6, so that can also tell you that it's not a function. Any questions over that? Yes?
Will we be asked that, like, to identify an ordered pair and see if it's a function, like the x's repeat?
I would ask you if the inverse is a function or not a function.
Okay.
That's what I'd ask. Okay? I wouldn't just give you ordered pairs. Any other questions? Okay, your homework is page 28. There's another page that to print out or pass out to you guys. There's only 2 more problems. Okay? So I'll get that to you guys too.